Hello, I'm Anna Mackay and this video is on confidence intervals, part 2 of 2, with 3 practical examples. Our first example here, we wish to determine the 95% confidence interval for the mean heights of adults. So how could you work that out? You would have to survey every single adult and to find their height and take the average of that. But that's not going to be possible. So we take samples. So a random sample of 100 adults is taken. So that's our N. The sample mean height is 150 centimetres, that's our X bar, and the standard deviation is 20 centimetres. So I'm going to go straight to the calculator and show you how to do that, and then I'll come back and I'll write it down here. So here we go. We have, for Casio's, menu 2, and then it's going to be using interval here, F4. That's what INTR stands for, interval. A Z, F1, and then F1 again, one sample. And then we input our data. So our confidence level is 0.95, that can be changed. Our sigma is 20, X bar was 150, and our N was 100. And we enter, and it gives you your lower and your upper bound, and it states what your X bar and N were. And so there are 2 endpoints. Let's go back and write them. And so that is an interval for mu. So we had 146.1 for mu and 153.9. I'm not going to get into the debate about whether it's equal to or not equal to. You can technically write either. And I'll just write off to the side the setting out that is you really need to write each time round. And the setting out is what appears in your calculator. So your confidence level was 95%, so 0.95. Sigma was 20, X bar is 150, and N was 100. And that is all the setting out that you need for a confidence interval. When they mark it in the exam, they're after the 2 endpoints. I'm just showing you here with the formula though. I'll just write it out once using the formula. You do not have to show it subbed into the formula and then equate it. But I'll just do it once for you. So our X bar is 150, subtract 1.96. Remember from the last video, that represents the Z score for the 95% interval. Sigma is 20 over the square root of N, which is 100. And less than or equal to mu, you must put mu there, it is not X bar. And then the right hand side interval is X bar, add on 1.96 times by 20 over square root of 100. And then you would calculate that to get this line up here. So there's our first basic example. Now, just a comment on this. This is what our confidence interval was that we found on the first slide. All values in this interval are equally likely. You need to remember that. The middle value, which is simply the value of X bar 100, which was 150, that is the middle value, right slap bang in the middle. That is not any more likely than any other value. So let's consider these following statements. It is very likely the true mean lies between 146.1 and 153.9 centimetres. Is that okay? Yes. So it's very likely that it's in between those. Next statement. The true mean could be 152. Think about where that is. Yes, that's within the interval. So yes, it could be. That's okay. The true mean could be 146.09. I've made an error there. I meant for that to be 146.11. Could that be true? Yes, it could. It's right at the lower end, but as this first statement said, every value is equally likely. What about this last statement? The true mean is, so it's definitely 146. Well, 149. 149 is in the interval, true, but we cannot be that certain. We cannot definitely say it is 149. Every value in there is equally likely, so that would be wrong, that statement. Just trying to get your head around that. Example 2. The IQ of, say, students has a standard deviation of 15, let's say, and a random sample of 70 students is selected and has a sample mean of 105. So this time around we want to determine a 92% confidence interval. But the first step is to determine the Z value, error there, determine the Z value required for a confidence level of 92. So from a 95% confidence interval, we know that that Z score is what? 1.96. So thinking 92%, smaller interval, so what might your Z score be? Bigger or smaller? Smaller. So what we're actually trying to work out here, I find it helpful to have a little picture, is in here is our 92%. Our mu is going to be in the middle, and we've got a Z score either side. So what's left over? The complement, 8%, and you have to evenly split that between the two endpoints. So we're going to have 4% data there and 4% there. And to work out the value of that Z, you do an inverse normal calculation. So I won't flick to the calculators, but feel free for you to check that I'm right. T for tail, left or right is fine. I'll go left this time around. And area, 4% as a decimal. Standard deviation of 1 and mu of 0. And that gives you a Z score of negative 1.75. So the question asked us to determine the Z value required for a confidence interval of that. And I would say that the Z value is the positive of that. Z value is 1.75. So that when you come to use it in the formula, you're not getting confused with double negatives. And then construct a 92% confidence interval. So each time round for confidence intervals, you need to show 4 steps of setting out. Your confidence level this time round is 0.92. Standard deviation was 15. X bar was, what was it? 105. And the other piece of information is N, which is 70. And that gives you a confidence interval of 101.9 and 108.1. Mu is in the middle because this is an interval for predicting the true population mean. Okay, and our third example. Jim took a sample of the waiting times for customers in a fast food outlet. His 95% confidence interval for the population mean was this. So that on average, that's the time people will wait, every person. What was our sample mean? What's X bar then? Well, the way to find that is it's halfway between the two endpoints. X bar is the middle of a confidence interval. So if you ever get asked a question like this, you just add up the two endpoints and divide by 2, and X bar is your answer for that. So find the confidence interval Jim would have calculated if he had used a 99% confidence level. All right, so what do we need to know for this? To do a confidence interval in your graphics calculator, you would need to know the standard deviation. You would need to know X bar. Okay, well we know that one, 1.1, and you would need to know N. That's 2 things that we don't know. So you might be a bit stuck here. So what could you do? Well, use this information that you've got. You've got these 2 numbers here. Here's our formula for a confidence interval. So I'm going to write that out, substituting in whatever numbers I do know. So here's our first one. X bar, N, well we know that one. That's 1.1. Take away the Z score. All right, well back up here for a 95% confidence interval. A Z score for 95 would be 1.96. Now, the next bit along, the standard deviation over the square root n. We don't know that. So I better just write that as it is. Between mu and now the other side. We've got 1.1 plus 1.96 times by sigma over square root n. Now we do know though that the left-hand endpoint calculates to be 1.0, and that I'm just going to do that a little bit higher because otherwise I might run out of room. And the right-hand endpoint comes out to be 1.2 when you calculate that. So let's just take this left-hand endpoint and equate that to this. So we've got 1.1 take 1.96 is equal to 1.0. Well, I'm going to represent these two unknowns by another letter. You could do star or whatever. I'm just going to do a y. And let's solve for y. So just some basic rearranging. I would get negative 0.1 here. Solving for y, I would get 0.051. So just remembering that y is sigma over the square root of n. So that's that part. Now let's see if that helps me working out the confidence interval. So I've written out the confidence interval formula here again. Let's substitute in what we know. So x bar n was 1.1, subtract a z-score. Okay, so we want a z-score for a 99% confidence interval. So we're actually going to have to work that out first. So 99%, you would do inverse normal for a z-score. Tail, I'm going to go right this time. Area. Now, what is the complement of that? 1% is left. And remember, you have to divide that complement for the two endpoints. So you take that 1% and divide it by 2 to split it. So if ever you get any confidence interval, you think about what's left over to take it up to 100 and divide that by 2, and that's the area that you'll put in there. Standard deviation of 1 and a mean of 0, and that gives you a z-score of 2.58. So that's the number that we're going to use up here now for our confidence interval. Next is sigma over square root n. Well, we calculated that before of 0.051, and that's not going to change for a 99% confidence interval. We'll finish this off. 1.1 plus this time 2.58 times by 0.051, and then you just calculate the two endpoints. So our 99% confidence interval for guessing, well, approximating what our population mean would actually be, the mean waiting times for all customers would be between 0.97 and 1.23 minutes. Okay, that's the end of this video, and the next video in the series will be called sample size. Thank you.